Hi everyone, I hope you're all doing well. This week we're going to talk about migration, and this is chapter 12 in your book. So with this, the book does a pretty nice job of covering a lot of the topics, but it kind of misses some of the things. So especially towards the end of this lecture, there's going to be some material in here that is not either in your book or it's not covered in depth enough from your book. So make sure that you pay attention to that added material. Here we go. So what is migration? So just to be clear, migration is a regular seasonal movement away from a breeding ground and then back to the breeding grounds later. Okay, so we need to make sure that we have migration differentiated from dispersal and then local movements, okay? So dispersal is going to be the movement of an individual from one breeding area to another breeding area, okay? A lot of times we get post-breeding dispersal where young will move off farther away to find a new territory later on. But here with migration, we're talking about this seasonal movement away from the breeding grounds. In North America, over 200 species migrate. A lot of our birds are neotropical migrants, which means that they go to the tropics, Central and South America for the winter. And actually, a lot of our birds are only here for a very short period of their life cycle. So, 2, 3, 4 months, and then they are somewhere else the rest of the year. So this makes migration a really major conservation issue. We really need to think about stopover and refueling sites, which we'll get into a little bit more. These areas are going to be really important for birds to stop at and refuel during the migration process. Unfortunately, migration is usually the highest amount of mortality that we see in a bird's life cycle. A lot of this mortality could be caused by weather. There are severe storm events that will come up and affect these migrating birds. So for an example, you might have seen the headlines of all these birds dying in the Rocky Mountains in September 2020. I'm not sure if they are definitive on all of this yet, but there was a drop from 40 to 40 degrees Fahrenheit from the 90s. There were really high winds, 70 miles an hour. And this really, this mortality event really seemed to disproportionately affect insectivores, and not just insectivores, but aerial insectivores, so the swallows and the flycatchers. And this is just one sample of what was collected. And again, most of these are flycatchers and swallows. You can see some warblers and other species mixed in here. Other causes of mortality, this would be more individual level with predation. Matt Schumer talked about lights out, so lots of collisions. Sorry, and in fact, some of you have found birds that have died due to collisions with buildings on campus this fall. So buildings, collisions during migration can be a major problem, as well as disease, especially when individuals are stressed. Maybe you're in a lower energetic state, you're more likely to be susceptible to disease. This figure shows with a few different species. This is one from your book, I believe, with daily mortality rate of 4 different species. And you can see the big thing is daily mortality in fall and spring during migration is going to be the highest. And again, if you're thinking about it, they're over the spring, summer, or the winter, they're on a territory. They're maybe in habitats where they're more familiar. They can figure out where the cats are, or where the buildings are, or where the food is. Whereas in fall and spring migration, they're coming into habitats that they're not as familiar with. So I'm going to take a step back once and remind us all to look at the older literature. So this is a report or in a scientific journal in the Auk, which is one of the main or top avian journals in North America. This is a report published by Saunders in 1906, particularly about northern saw-whet owls. I had found it whenever I started working with northern saw-whet owls, and wanting to understand their migration. In 2003, unfortunately, people were saying, well, do northern saw-whet owls migrate through Ohio? And do they migrate across the lake? Well, we forgot to look at this older literature. So somebody that was very good at cataloging some of this older literature sent this to me. So this is a northern saw-whet owl. This is a picture that I took in New York State. You can come up to these. I was within a couple feet of this bird when I took the picture. Now, I might be listening too much to This Podcast Will Kill You. If you haven't listened to that podcast, you really should. It's super fascinating. And it's much better to listen to go to sleep than some other things that you could find. So anyways, they always often start out with a story. So here, I'm going to read to you. You can skip through if you don't want to listen, but please at least take the time to read. So, a migration disaster in Western Ontario. The early days of October 1906 were warm and damp, but on the 6th came a north wind which carried the night temperature down to nearly freezing. Near there, it stayed with little variation until the 10th, and on the 10th, the north wind brought snow through the western part of Ontario. At London, there was only 2 or 3 inches, which vanished early the next day, and the thermometer fell only to 32 degrees on the night of the 10th, and to 28 on the 11th. But 10 miles west, there was 5 inches of snow at 5 p.m., October 10th, and towards Lake Huron at the southeast corner between Goderich and Sarnia, the snow attained a depth of nearly 1.5 feet, and the temperature dropped considerably lower than at London. On that night, apparently there must have been a heavy migration of birds across Lake Huron, and the cold and snow combined to overcome many of them, so that they fell in the lake and were drowned. Thanksgiving Day fell on the 18th, and Mr. Newton Tripp of Forest spent the day on the lake shore near Port Franks and observed hundreds of birds on the shore dead, cast up by the waves. He wrote me about it the next day, calculating 5,000 dead birds to the mile. And I took the first train to the scene of the tragedy and drove out to the lakeshore that night. On the morning of the 21st, I patrolled the beach south from Grand Bend, and after covering several miles and seeing only a few dead birds, I came at last to the region of death. At first, the birds were not very close together, but eventually became so plentiful that in one place I put my foot on 4 and saw as many as 12 in a 4 or 5 feet. I began a census at once, which I continued until the lengthening shadows warned me to hurry on to the river so as to cross in daylight. But in the 2 or 3 hours I spent in the count, I recorded the following. So a large number of birds. I'm going to quit reading to you now. You can finish if you want. One, I just love that at one point we were able to write like that as naturalists. But again, I think what I'm trying to show you here is we do know that birds do migrate over water. We do know that they will migrate into mixed species flocks. And while birds are very good at detecting changes in weather that are coming, and there's really miraculous stories of birds flying 500 miles out of the way of an oncoming storm, birds still get caught up into these storms and can perish. So, that goes to the question then, why do birds migrate? And what trade-offs are there with migration that makes it beneficial enough to come north to breed every year? And this is something that one of you had asked when Dr. Sherry was visiting. So again, we have to be thinking about this trade-off in survival and reproduction. Overall, tropics do have high nest predation, okay? Whether it's from army ants or there's all kinds of things that can damage and destroy a nest. So we can look over here at this table. So when we look at annual adult survival in the tropics, tropical residents have high survival. Migrants, intermediate survival, adult survival, and temperate residents have low adult survival. So you think about some of our chickadees or titmice, well, some of them can live a really long time. Adult mortality is much higher in those populations that stay here year-round. When we then look at reproductive success, though, we see that in the tropics, annual reproductive success for tropical residents is low. Migrants, the ones that are coming north, at least for our birds, have intermediate reproductive success, and temperate residents have high reproductive success. So this is where we start to see, they're making, each species is making a decision, and what is most successful works out for them. So again, kind of going back to this point of when adult mortality is, Sillett and Holmes, again up at Hubbard Brook Experimental Forest, they actually looked and estimated adult survival at different times of the year with their banded population. So again, summer adult survival is like 99%. Winter survival on the wintering grounds is about 93%. But autumn migration between 0.67 to 73%, and similar on spring migration. So migration is where we're seeing this mortality. But again, if these birds can get out intermediate or better reproductive success than they could in the tropics, it's enough of a reason to move northward. And of course, those with the highest reproductive success in the long run end up increasing. So again, when we're thinking about why these birds are migrating from the tropics, where there's probably really high food availability. But when we think about our northern latitudes, if we think about the boreal forest in Canada, if we think about even above that in the tundra, there is a huge amount of arthropods available because of the sun, the radiation, the solar radiation, the energy input. We also see this really high amount of life that comes out of that. These birds are coming up and able to raise their young during the shorter summer months and take advantage of these resources. One thing that I wanted to kind of point out, I pulled this graph because it does show number of insects, dry mass of arthropods and traps over different time periods. In this, I'm sorry, let's see if I can do that. All right, there we go. So June, July, and August. We can see, of course, that we have these really high numbers in the summer. Okay, but over the years, we're starting to see some shifts. So this paper was about his prey availability for Arctic birds advanced with climate change. And this is something that we're going to have to really think about, with phenology and migration. Are these birds able to get up there if this peak of insect abundance in 2002 isn't happening until July? Is that enough time for them to get their young raised and on their own enough so that they can successfully migrate south? So lots of research that needs to be looked at into this, but I do like how this does highlight the number of arthropods that are available during the season. So if you think about it, migration is a really amazing thing. If you asked me to even migrate out of the state on foot each year, that would be a feat for humans. But these birds are making sometimes really long journeys. So the book does a good job of talking about some of the extreme examples. Some of the extreme examples of bar-tailed godwits this past year. Bar-tailed godwit actually broke the species record for the most long distance flight. So a bar-tailed godwit flew 7,500 miles from the Arctic to New Zealand. And here you can see what the bar-tailed godwits look like. And then you can see they're taking off up on the northeastern coast of the United States. They're often flying the whole way across the northern part of North America, and then staging here and then making these non-stop flights to New Zealand. Pretty amazing. A related species, this is a Hudsonian godwit, so this is an example in your book showing that they breed anywhere up along in here, but our breeding population that's up here in Alaska, they end up flying east across North America. They'll have some staging grounds, and then fly the rest of the way to the East Coast, and then fly over the Atlantic, stop over in northern South America, and then fly down and overwinter in the southern tip of South America. And then again, on the way back north, they'll make this really long flight down here off the coast of Argentina or Chile, if I knew my geography better, and then making these nonstop flights up into the U.S., where they're landing in our central Midwest, and then heading back up to their breeding grounds again. The Arctic tern also makes incredible flights. Their round trip flight each year is 25,000 kilometers. And that's showing some of this path in here. It's not the same direction each year, and it depends on where they're coming from. Lesser yellowlegs, which some of you may have seen this fall, lesser and greater yellowlegs are often hard to tell apart. But lesser yellowlegs are known to fly 3,200 kilometers in just 6 days. And that was a nonstop flight from Massachusetts to Martinique in the West Indies. There's also many raptors that migrate. There's Hawk Mountain in Pennsylvania, which is a really well-known site to go and watch the raptor migration. A lot of times, anytime you have these mountain ranges, the hawks will be migrating during the day. They're one of our fewer nighttime or daytime migrants, and they can take advantage of these thermals, the thermal lift from mountain range. So lots of sites where you can look at that. A couple of examples, and I do have links here. So please, on the PowerPoint, go ahead and check these out and look at some of this information. Pronatura in Mexico is a huge site, and it actually has on their website then, they have like daily tracking. So you can always see what's moving through on a daily basis. So a few more examples of long distance migrants. I put in here each of these species so that you can see. This is again from Cornell's Birds of the World site, so you can see, and then also the family and order that they're in. Again, most of these are not birds that you're required to know, but it's a good idea to always just remind yourself what families different birds are in. So this northern wheater is represented by this blue line. So they're breeding up here, they're breeding up in Alaska, and they're making these flights across Russia and then Asia into South Africa. And you can again see their breeding range here. So even these birds, they don't end up coming down just across this way. They actually go the whole way across this continent. Arctic terns I already mentioned with the red here. This one, merfalcon. Falcons are always cool. We can always think about it. So here we have the breeding and wintering range, and you can see how they fly. Not quite as long. But anyways, I think it's really cool to think about how some of these birds migrate and what their paths are. I do want to bring up the Swainson's hawk. So the Swainson's hawk was mentioned before, I think in speciation or another chapter. So they typically migrate through here. They were thinking about with the Galapagos hawk. We talked about that. The Galapagos hawk, if you remember, two males will partner up and help defend a territory and breed with one female. And they were thinking that the Swainson's hawk was basically got off course, landed in the Galapagos, and a small population there ended up evolving into the Galapagos hawk. So some speciation because of isolation. So not a beautiful slide, but I wanted to talk a little bit more about these flyways. I had already mentioned that raptors will be using flyways, and they'll migrate along these corridors, often along mountain ranges. And this figure 1216 from your book shows you the migrating raptors concentrating in these corridors. And again, they tend to follow mountain ranges. And same thing somewhat in Europe and Asia. Here are the 8 major flyways for migrant shorebirds. So we have the Pacific Flyway, we have the Mississippi American Flyway, and then the Atlantic Flyway over here. So those are the 3 main flyways that you might hear about in North America, especially when you're working with conservation efforts. Other flyways in the Old World, the East Atlantic Flyway here takes birds from northern North America, Greenland, end up flying across to Europe and down to South Africa, or the southern coast of the African continent. So something to think about with our flyways, and again, the differences in the Old World versus the New World is the orientation of the major landforms. So when we're thinking about the mountain ranges, the Rocky Mountains and the Appalachian Mountains all have a north-south orientation. and that affects how migration occurs throughout. And it also affected migration during the last ice age, during the Pleistocene and previous ice ages as well. There was always a corridor north-south for these birds to be able to move in. This is an updated, I need to get this poster, updated poster from 2018 from National Geographic that shows different species and how they migrate. Unfortunately here it's probably too small to read, but it also talks about each of the migration paths for a variety of different species. So I do love this poster. When I do public education talks, I usually take this poster out and put it up and then use that to provide some examples and allow people to look at. So it's a really good thing. If you end up doing some public education things, there's some fun migration station activities where you can teach kids as young as 2nd grade to navigate with a compass and to learn about the perils of migration. So if they navigate incorrectly, they end up maybe getting killed by a cat, or running onto a desert island where there wasn't enough food, or running into a building or skyscraper. So it's a really cool activity. So if you ever end up doing some public education with kids and want a fun activity where kids can get up and move around while still learning about migration, I do have an activity for you, so feel free to contact me. So going back and talking about the Old World now, again, when we think about the landforms there, whether it's the Alps, Mediterranean Sea, the North Sea coasts here, North Sea, and then the Sahara Desert as well, these landforms provide an east-west barrier, which is going to affect birds that are migrating north to south. So they have to go over these barriers if they are going to migrate, or they have to go around them. And really, there's no way, just like our Gulf of Mexico, there's few ways for them to get through that. So a lot of times birds just have to migrate through or over. So don't get too caught up on this slide. I did just want to bring this in. I don't know the geography because I've never been there. But if you're familiar with any of these areas, you can look up. There's a key. But again, just kind of highlighting some of these migration corridors in the Old World with some of these birds, including the Pacific golden plover, the whimbrel, and the dunlin that migrate through this area. So when we're thinking about shorebirds and shorebird migration in the Americas, there are again some very important flyways and stopover locations. So this, if you click on the Western Hemisphere Shorebird Reserve Network, I can bring this over. I think I've got it pulled up. They have a lot of really cool information at their site. Plus, you could just watch these little videos of these shorebirds all day long and try to identify them. Maybe that's what I need to do. Spend some time on that. But anyways, there's all kinds of information here. It talks about the network, how many million acres of shorebird habitat, and then they also have sites in the Americas. And this is a kind of cool interactive map if you want to get in there and spend some time on that. But in general, what I wanted to kind of bring up here is, again, thinking about these flyways and how many birds are actually using these. And this was from 2007, and we've seen major declines in some shorebird populations since. So these numbers may be off and be lower now. But if we think about it, these shorebird network sites host more than 500,000 shorebirds, 30% of the flyway population. So if you have a threat at some of these flyways stopover sites, then you could have serious reductions in numbers of birds in these. When you have the little triangles over here, the triangle ones hosting more than 100,000 shorebirds, or 10% of the flyway population. The round dots in these different areas over here, these are round dot areas, are signifying spots that host more than 20,000 shorebirds. And it also, this is really nice because it has the dark lines are for the spring migration, so these are going north, and then the gray lines are the fall migration going south. So some really important things to be thinking about if you're working in conservation at all, and where do we want to protect and conserve land. So here I want to focus in on the Pacific American Flyway. Okay, so this was on another slide earlier with the different flyways, but here we're going to just focus on the Pacific American Flyway. And I'm going to highlight over here some of the species that use this flyway. So as you read about these, you can come over here and look at the species to remind yourself what they are. So up in this area, this Cooper River Delta is an important staging site for waders, including 4,100,000 western sandpipers and Dublin. So these two species here. I can't even imagine those numbers of shorebirds. And then over here, let's see here, we have the Stikine River Delta here in the U.S. And again, this is important for waders, including western sandpiper. We have here the Boundary Bay, 30,500 American widgeon use this area. So here, one of our ducks, family Anatidae. American widgeons this is a critical stopover spot for them, as well as Dunlin and sandpipers. Down here, we have Panama. So the Upper Bay of Panama is one of the most important areas for migratory waders. And again, million western sandpipers, 165,000 semi-palmated sandpipers, and 30,000 semi-palmated plovers. So again, pictured on here, the plover and the sandpiper here. So really critical areas. And then in South America, we have in Ecuador, there's coastal lagoons along here that host the phalaropes, the Wilson's phalarope here. And then in Peru, we have a coastal area with large numbers of these elegant terns, which I've never seen before. So really cool birds, and you can imagine just how important, there's so many birds concentrated into these areas, how important the food resources are there, the importance of the ecosystem health in these areas is going to be so critical for maintaining populations of these birds. Okay, because this is a little bit longer of a lecture and I have to go to field ecology right now, I'm going to stop here and I'm going to do this in at least 2 parts. So make sure you find the next part of the lecture posted also on YouTube.